Now, finding the derivative allows us to find the gradient of the tangent at any point that we care to investigate. So if we can find the gradient of the tangent, then we can also find the angle of inclination of that tangent. Now, the reason we can do this is because we know how to find the gradient. We just differentiate our function, and then we plug in whatever value of x we're interested in. And then we've also learned in our coordinate geometry work that the tangent of any angle is equal to the gradient of that line. So let's have a look at how this works. Let's find the angle of inclination of this function, it's a parabola, at the origin and at the point minus 2, 0. Now, for some of you, it's going to be really helpful to graph this first, just a quick mud map graph. It doesn't have to be perfect. You know this is a parabola because it's got x squared, and you know that it's upright because the coefficient of x squared is positive. Quickly factorising this, I can see that I can factorise it like that. So to look at where the x-intercepts would be, all I have to do is let y equal 0, or let f of x equal 0. And I can see that if this was to equal 0, I'd have something times something where one of them needs to be 0. Either x is 0, or x plus 2 is 0, in which case x would have to be minus 2. So I can tell the intercepts are at 0 and minus 2, which is one of the points I've been asked about later. So this is helpful for graphing this. And I know it's an upright parabola, so it's something like that. So what the question is basically saying is find the angle of inclination of the graph. Now, to find the angle of inclination of the graph at that point, here and here, we really just want to find the angle of the tangent, because the tangent at that point is exactly the same angle as the graph. And over here, the tangent at this point, we want to know how steep it is. Now, the angle of inclination is always measured from this side, remember? So we want to find this angle here, let's call that alpha. And we also want to find this angle here, let's call that beta. Now, straight away, if you've drawn a diagram, you can really clearly see what it is that you need to do. Now, to find the gradient of the line, first I need to differentiate. So over here, I don't want to differentiate this one so much. I'd rather work with this one because it's listed in separate terms. So I factorised it so that I could graph it. But I'm going to work off this now and say f dash x equals, now differentiating x squared, I get 2x. And differentiating 2x, I get 2. Add those together. Now this is the gradient function, or the gradient recipe. It helps me find the gradient at any point I want to investigate. So I'd like to investigate when x equals minus 2. What's the gradient there? So I find f dash minus 2, and I find that by plugging in minus 2 anywhere that was in x, that they had an x in the gradient function. So I've got two lots of minus 2, if you like to write it like this to clearly see what you're doing, and then add 2. So I've got minus 4 plus 2, which is minus 2. So the gradient here is minus 2. That looks about right. It's definitely a negative gradient, isn't it? So check that your answer always makes sense. It's negative, it looks about the steepness of 2, even though I've just done a rough sketch. Now, f dash 0 will give me the gradient when x is 0. So how do I find it? Well, I just use this recipe and I plug in 0 for x. 2 zeros is 0, plus 2, I can do that in my head, that's 2. Does that look like a gradient of 2? Yeah, that seems about right. Now I need to use this. The tangent of an angle is equal to the gradient. So if I know what the gradient is, let's do this one first. No, actually, let's do this one first because it's an acute angle, so it's going to be much easier. If I say the tangent of alpha is equal to 2, because here's alpha, and the gradient of this line here is 2, then how do I find alpha itself? That's right, I need to find the inverse tangent of 2. So, reaching for my calculator, I type in shift tan 2, and I get alpha 63 degrees and 26 minutes to the nearest minute. Okay, that's done. Does this look like it would be about 63? Yes. Okay, so I can label that if I want, 63 degrees and 26 minutes. Okay, what about this other one? Well, a gradient of negative 2, write it down and have a look at it. Tan of beta equals negative 2. Now, what do you know about quadrants? Let's think. We're in the second quadrant here. This is an obtuse angle, isn't it? We can tell because it's a negative gradient. So, actually, if we could find this angle here and subtract it from 180, we're going to have beta. Beta equals 180 degrees minus the tangent of 2. And we already know what that is, it's 63. So we can put 180 minus our answer, and that gives us beta at 116 degrees and 34 minutes to the nearest minute. Now, if you had actually just put in inverse tan negative 2, what you get is negative 63 degrees. So you've got to be really careful not to do it that way, because angles of inclination are always between 0 and 180. And so you know that negative 63 is the same as 116, if you're thinking that through. But the picture's going to really help make sense of it.